In this video, I'll give you an overview of the Nagell-Lutz theorem, which has to do with points of finite order on elliptic curves. Suppose that y squared equals x cubed plus ax squared plus bx plus c is a non-singular curve with integer coefficients, so a, b, and c are integers. And let d be the discriminant, which is given by this formula. Negative 4a cubed c plus a squared b squared plus 18abc minus 4b cubed minus 27c squared. Now, by the way, when I say that the curve is non-singular, then that means that the discriminant is non-zero. Now, if P is a point on the curve that has finite order, then the Nagell-Lutz theorem tells us two things. First of all, the coordinates x and y are both going to be integers. So only integer points on the curve are going to have finite order. And also, the y-coordinate of the point is going to either be equal to 0, in which case you have a point of order 2, or the square of y is going to divide the discriminant. So this really narrows down the number of possibilities of points of finite order. In fact, it means that you can find all of the points of finite order in a finite number of steps. You start off by calculating the discriminant, which will be non-zero, and then, one at a time, you look at all the perfect squares which divide into D. Substitute those in over on this side, and then that gives you a cubic polynomial. You can use methods from pre-calculus to check all the roots to see if there are any integer roots to that polynomial equation. And if there are, each one is going to be a possible point of finite order. And then for each of those possibilities, you can find multiples of it and see whether it circles back to 0. When you're looking at multiples of P, if at any point you get a point which has fractional coordinates, then you know that the original point cannot be of finite order, because all the points of finite order have only integer coordinates.